Alrighty, everybody. Hope this video is finding you guys doing well. We're going to be jumping into 11.3, dividing polynomials. So we're going to start off kind of easy, dividing a polynomial by a monomial. So this is our trinomial polynomial, which is being divided by a monomial, a single-termed monomial. So again, we're not going to be using this division sign very often anymore. So what this thing is telling us, the parentheses are extremely important. This entire trinomial, each of them is being divided by 3x squared. So, or the whole thing is. So another way of being able to write this, and this is the more correct version that you are going to be seeing for now on, is that the entire thing of 9x cubed minus 6x squared plus 15x is being divided by 3x squared. Now what this means, the entire thing is being divided, which means that every single entity separately is being divided. This is called splitting up fractions. If you are adding and subtracting fractions together, the only way to add and subtract fractions together is if they have a common denominator. The common denominator in this sense is 3x squared. So the denominator of 3x squared is actually a denominator of all three of these fractions. So you're taking this fraction and you're subtracting this fraction and then adding it with this fraction, which creates this bigger fraction up here. But because I can separate them all out entirely, now you will recognize that each of these is actually reducible. 3 divides into 9 3 times, and x squared divides into x cubed, leaving just x. 3 divides into 6, making it a 2, and x squared is just 2. Plus 3 goes into 15 5 times. However, the x in the top goes into the x squared in the bottom, leaving an x. And that would be your answer. 3x squared minus 2 plus 5 divided by x. So let's try it again over here. We have this entire thing being divided by that, which would be 4a to the third plus 10a to the second plus 3a, all divided by 2a squared. That means that each of these individually is being divided by 2a squared. So you have 4a to the third being divided by 2a to the second. Adding that with 10a to the second divided by 2a to the second. Adding that with 3a divided by 2a to the second. So again, 2 divides into 4, making it a 2, and a to the third divided by a to the second is a single a. 2 goes into 10, making it a 5, and a squared divided by a squared is 1. Plus, 3 and 2 does not reduce, so I still have a 3 over 2. A goes into the a to the second, leaving 1a on the bottom. 2a plus 5 plus 3 divided by 2a. However, dividing a polynomial by a binomial, this is a little bit different. Do you remember your long division that you learned in 3rd, 4th, 5th grade? If you don't, let's do a real quick refresher of long division. So let's say I'm taking 7, and I want to divide 7 into, let's say, 1,462. Okay? Well, how would I divide 7 into 1,462? So I first ask myself the question, does 7 go into 1? And no, 7 doesn't go into 1 at all. So then I have to go to the next value over and ask myself, how many times does 7 go into 14? Well, 7 goes into 14 twice. That's a 2. Then I take this 2, and you multiply the 2 to the 7. 2 times 7 is 14. However, you then have to subtract this 14 to that 14, getting a 0. And then you bring down the 6. And then you would ask yourself again, does 7 go into 6? But 7 doesn't go into 6. So I put a 0 right here. And then I got to bring down the 2. And then I would ask myself, how many times does 7 divide into 62? 62 divides into 7 8 times. But then you take the 8 times the 7, and 8 times 7 is 56. And then you subtract the 62 and the 56, which is 4. No, not 4, 6. 62 minus 56 is 6. Now, what happens with this 6? This 6 is called the remainder. Okay? It literally remains. It's your fraction that is left over. Okay? So 7 goes into 1,462 208 times with a remainder of a fraction of 6/7. This is called long division. We are going to do the exact same thing, but with polynomials. So let's go back to the front. We are going to do the exact same thing, but with polynomials. So I'm going to take the d plus 3, and I'm going to divide the d plus 3 into 3d squared minus 4d plus 13. Now, I'm going to ask myself, how many times, and then you only look at the d here in the front. You look at the d. How many times does d go into 3d squared? Now, another way to ask yourself that exact same question is, what do I have to multiply d by to get 3d squared? Well, the answer is 3d. 3d times d is 3d squared. So, I now multiply the 3d to this entire thing. You have to distribute it. You have to multiply this to this and to this. So I take 3d times d, which is 3d squared. And I take 3d times 3, which is a positive 9d. However, I now need to subtract this entire thing. So I subtract this one, but I also have to subtract this one, just like we did on the back. You divide it in, you take that number, you multiply it down, and then you subtract it. But since we're not subtracting a single entity, we're subtracting two, you must subtract them both. This goes away, and it should, it better. If you've done it correctly, this needs to go to 0. Negative 4 minus 9d is negative 13d. And then I ask myself that question again. What do I multiply d by to get negative 13d? Negative 13. I take this negative 13 and I multiply it to this whole thing. I distribute it. I multiply it to the d and I multiply it to the 3. So I take negative 13 times d, which is negative 13d. And I take negative 3 times 3, which is a negative 39. I bring down the positive 13. And I subtract, which in this case is really adding both of them. This goes to 0, as it should. And 39 plus 13 is 52. Now, what do I multiply d by to get 52? Well, since this 52 doesn't have a d with it, the answer is you can't. You cannot multiply d by anything to get 52. So this is, again, your remainder. Now, just like on the back, our remainder remains being divided by this thing that's doing the dividing. This 6 is divided by 7. Well, that's exactly what's going to happen here on the front. Our answer is 3d minus 13 added with, because this is positive, a 52 being divided by a d plus 3. The 52 is still being divided by d plus 3. And that is our first problem. Let's try it again. So I'm going to take the m plus 1. Now this is, again, we're not going to be seeing the division symbol very often anymore. This is how it's going to be written. This is how we show division from now on. So m plus 1 is divided into the entire thing. So I have to take m plus 1, and I'm going to long divide it into 2m squared minus m minus 3. First question is, what do I multiply m by to get 2m squared? The answer is 2m. I take the 2m and I distribute it to m and the 1. 2m times m is 2m squared. 2m times 1 is 2m. Subtract, and don't forget to subtract the second one. That's the biggest problem. You don't just subtract the first, you subtract both. You have to distribute that minus sign. This goes to 0, as it should. Negative and a negative 2m makes negative 3m. Then I ask myself the question again, what do I multiply m by to get negative 3m? The answer is negative 3. Take the negative 3 times m. Negative 3m, take the negative 3 times 1, which is negative 3, bring down this negative 3, and subtract both of them. So this goes to 0, and this goes to 0. So this is kind of special. Our remainder is 0, which means that this thing divides into this thing evenly. If you were to take m plus 1 and multiply it by 2m minus 3, you're going to get 2m squared minus m minus 3. This is essentially another way to factor. So the answer to this question is 2m minus 3, because it goes in evenly. Try it again. All right, you're going to recognize on this problem we have something going on. It's not written in what we call standard form. Excuse me, I need to get my dog. Jax. Sorry about that, guys. My dog was barking. All right, so we need to first write these in standard form. So I'm going to rewrite them as 4x squared minus 10x, then minus 1. And that's going to be divided by 2x minus 3. It's important to write them in standard form because you have to work your way down from largest degree terms to the smallest degree terms. So 2x, what do I multiply 2x by to get 4x squared? The answer is 2x. So 2x times 2x is 4x squared. And then you take the 2x times negative 3, which is negative 6x. I subtract both of these. This goes to 0 as it should. Negative 10x plus 6x is negative 4x. And then I ask myself the question, what do I multiply 2x by to get negative 4x? The answer is negative 2. I take negative 2 times 2x, which is negative 4x. I take negative 2 times negative 3, which is positive 6. You bring down the minus 1, and you subtract both of them. This goes to 0 as it should, and this is negative 7. So negative 7 is the remainder. So this does not go in evenly. So if I take 2x minus 3 and I divide it into 4x squared minus 10x minus 1, you get left with 2x minus 2 minus 7 still being divided by 2x minus 3. The remainder remains over what was doing the dividing. Try it again. Write it in standard form. 18a squared plus 21a plus 2 is being divided by 6a plus 5. What do I multiply 6a by to get 18a squared? The answer is 3a. Take 3a times 6a gets 18a squared. Take 3a times 5, which is 15a. Subtract both of them. This goes to 0 as it should. 21 minus 15a is 6a. What do I multiply 6a by to get 6a? The answer is 1. That 1 is important. You got to put it there. 1 times 6a is 6a. 1 times 5 is 5. Bring down the 2 and subtract both. 6a minus 6a is 0, as it should be. 2 minus 5 is negative 3, my remainder. So the answer is 3a plus 1 minus 3, still being divided by 6a plus 5. And there you go. Dividing polynomials. We got a word problem on the back. The width, W, of a rectangle is 3x minus 1. The area, A, of the rectangle is 18x to the third minus 8x plus 21. What is an expression for the length of the rectangle? This is a very common problem we have done many times. The area of a rectangle is found by taking the length and multiplying it by the width and getting your area. So we don't know the length, but we do know the width. We have the length times the width, which is 3x minus 1, equals 18x to the third minus 8x plus 21. Now, something very special going on here. This is a cubic. It's a degree of 3. This is a linear. It's a degree of 1. What's missing? There is a missing entity between the third and the 1. It's 2. It goes 3, 1, 0. We skipped the 2. This is really important because when I divide it, we must put a 0 in for that missing quadratic. So we solve by dividing by 3x minus 1. And now the question is what is this? The length is going to equal 18x to the third minus 8x plus 21 divided by 3x minus 1. So whatever this divides out to be is going to be our answer. So this is what we've been doing. We've been dividing a polynomial by a binomial. However, this is a little bit different because we are missing a term. So when I put it into my long division here, you must put a 0 x squared for where the x squared is missing. This must go 3, 2, 1, 0. You must put a missing there, a 0 there. So what do I multiply 3x by to get 18x to the third? The answer is 6x to the second. 6x to the second times 3x is 18x to the third. 6x to the second times a negative 1 is a negative 6x to the second. Subtract both of them. This goes to 0 as it should. Add these, and now you have 6x squared. What do I multiply 3x by to get 6x squared? The answer is 2x. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Bring down the negative 8x. Subtract both of them. 6x squared minus 6x squared is 0. Negative 8 minus 2 is negative 6x. What do I multiply 3x by to get negative 6x? The answer is negative 2. Negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. Bring down the 21. And subtract both of them. Negative 6x plus 6x is 0 as it should be. 21 minus 2 is 19. So it does not divide in evenly. This is your remainder. Once you get down to no more x's, once you get down to what's called a constant, that's your remainder. So the answer to the question is 6x squared plus 2x minus 2 with a remainder of 19 divided by 3x minus 1. That is your length. I understand that that's not a very nice length, but that is the polynomial for the length of the rectangle. So that is how you long divide polynomial or rational expressions. Okay? That is very, very similar to long division that we did earlier. Yeah, you just saw my finger. Maybe you saw it the whole time. I cut my finger yesterday doing some work, and so I got a bad Band-Aid there. All right, people. 11.3, dividing polynomials. Please work on that this week. There's only a couple weeks left. We are going to have a test, one more test over Chapter 11 before the semester ends, which means maybe one of these weeks we might have to do 2 lessons instead of just 1 lesson in the week. So I'll give you a heads up when we do that. But as of now, go ahead and spend some time on dividing polynomials. 11.3 Math Excel will be available, and hopefully you can get that done this week. Thank you all. Bye-bye.